So let's look at solving simultaneous equations and what that means. This is not a way to solve simultaneous equations, it's to understand what we mean by solving simultaneous equations. So let's take one equation, which is this: x plus y is equal to 10. So let's take another equation, x plus 2y is equal to 12, right? Or what should have been 13? Okay, let's take 13. So now what this means, we've also seen, is that I have a starting point, and then I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have a starting point and an ending point. And what we are saying is, what value of x would satisfy this and this at the same time. So it has to be a value of x and a value of y that satisfies this and also satisfies this. So you can see if it was x plus y equal to 10 and x plus y equal to 12, it's not possible. You can't have the sum of the same variables equal to two different values. You can only have two different expressions having two different results. Only that is solvable. It's not possible to solve x plus y equal to 10 and x plus y equal to 12, for example, because the addition will either be 10 or 12, not both. But here what you are saying is, you are picking a value of x, some length of x, so that the x plus y will be equal to 10, but it should also satisfy x plus 2y equal to 13. Right? So for example, if I took 5 and 5, x plus y will be equal to 10, but x plus 2 times 5 will be equal to 15, not 13. So that cannot be a solution. So you can draw different lengths of x. So you can say, okay, my x is 3. And then what is left for y? 6 is gone, 7 is left, right? Then 7 will be y and x will be 3. But does this satisfy? Sorry, I made a mistake. I have done 2 times this, so that can't be. So this is y is equal to 3. I made a mistake. Pause. Okay, I did not mean to give out the answer, but anyway, it turned out that way. So there are 2 y's, 3 plus 3, and what's left for x is 7. And it turns out that this is also equal to 10. But otherwise, if we had taken different numbers, what it would mean is, I have an x, right? And then I have to split this in 2. Now 7 doesn't work, so I have to do this. And then I have 2y, 1, 2, 3, 4, and then 1, 2, 3, 4. So I'm coming till here. So this is 1y, this is 2y's, but this addition from here to here should be 10. Now this is x plus y should be equal to 10. Man, I'm very confused. Pause. So here my y value was 4 and my x value was 5. But the total of 5 plus 4 is 9. It's not 10. Right? So this should have satisfied, this length should have satisfied 10. Which is here. But I didn't get there. I got here. So if I take x as smaller, even smaller, let's say 4. But then this will become an odd number which I can't divide neatly. But that's okay. One, 2, 3, 4. Then 2y is the rest, which is 9, which means the middle point is 4.5, which is here somewhere. So then my x plus y, x being equal to 4 and y being equal to 4.5 is 8.5. Now this is going in the wrong direction. It's becoming smaller and smaller. So if my x is becoming smaller, my length is becoming smaller. I want to get to 10. I want to go the other direction. So then I have to increase the length of x. So this had come up to 5. Next, let's say I use x as length of 6. Then y will have to share 7, which is 3.5, which means x plus y has now become 9.5. You can see, you can progressively see every time I'm changing x by 1, my total is changing only by half, 0.5. So that means when x becomes equal to 7, which was the original solution, right, which I had drawn incorrectly. So when x becomes equal to 7, then what is left is 6. So y can be half of that. So y is 3, x is 7, and the total, as you can see here, has become 10, which is what we started with. I wanted x plus y to be equal to 10. Okay, so if I overlay the two, then the solution among all these that I have actually selected is this one, where your x was equal to 7 and y was equal to 3. So this is another way you can solve. It's not that you can't solve, but the graphical way in which two of these curves intersect, which has all the solutions already. So when you draw a graph, you get all these solutions. You also get all these solutions. So where both the solutions are the same is a solution for both the equations.